In this tutorial we are going to import vectors from CAD drawing software which come in the file format of DXF. We'll look at the properties that get imported and some of the problems that you may encounter along the way. We also look at machining mortise and tenon style joints on CNC machines and how to overcome fitting issues with dog bone fillets. So let's start by opening a fresh copy of the software, and we'll start by creating a new file. And for this we're going to specify a width of 42 inches and a height of 38 inches. We're going to specify the Z0 to be off the top of the block, and we're going to specify a thickness of 3/4 of an inch. For this job we're going to specify our XY date and position to be in the lower left hand corner, and we're going to be working in inches. Once we've got that, just press OK. So the first thing we're going to do is we're going to import vectors which we have created using a CAD drawing package. So to do this we go under File Operations and we use this option to import vectors from a file. So just click that and then navigate to the project folder and find the 3LeggedStool.dxf. DXF files are a common file format amongst many of the CAD design packages. We also support .dwg, .eps, .ai amongst some. These could be created in such programs as CorelDRAW, Adobe Illustrator and Inkscape, to name some. So once we've found our file, just simply click on it and then come to the open button and click on that as well, and that should then import our vectors into our job. The first thing you may notice is that the vectors that we wanted to import haven't appeared on our work area. This is quite a common occurrence when importing vectors from any other CAD drawing program, and the reason for this is that when you actually import these vectors you also load in the position data as well. So it all depends on where you were saving the vectors when you were creating these on the CAD drawing program. In this situation I can see that the vectors have been imported just off our work area down here. So if we just scroll back with the mouse wheel in the 2D view, we should be able to get a full view of the vectors that we have imported. On some occasions we may not even see any of the vectors at all. So the best thing to do in that situation, as long as the positional data that has been imported in is not relevant, we can simply go to Edit, we can then select all the vectors, and then we can then center those into the middle of our work area by going to Align Selected Objects and then selecting to align to the dead center of our work area, like so. As we have seen, importing vectors from a different CAD drawing program can also import its positional data that it was last saved with. With DXF and DWG files, you can also import any layer information that it was saved with also. So we can take a look at this by going to the Layers tab down the bottom, and we can see that it has imported a few layers. Layer 1 was our default layer, and these other 4 are the layers that have been imported. Not all of these layers, however, have actual vectors on them, and we can tell that by looking at the third symbol along on each layer. And if it doesn't contain the shapes on them, like these 3, it means that there's no vectors on that layer. And we can tell this by simply coming over to the bulb and we can turn that layer off, and you'll notice that nothing disappears. So we can delete this layer by right clicking and then pressing delete, and do that again for the default layer. And now we can investigate the layers that it has imported. So if I just go to the top part and then I just turn that off and then turn on, and you can see which vectors are represented on which layer. Now there is a tutorial dedicated to using layers and layer management, and I recommend watching it if you would like to learn more about how to use layers and how they can benefit you in organising your work. But for this tutorial I'm going to keep the layers as they are. So I'm going to head back down to the Drawing tab, and now I just want to zoom in a little closer to our vectors. So we can do this with a number of options. We can either use the zoom box to draw a rectangle around our vectors, and that will bring us closer in, or we can use, while the actual vectors are still selected, we can use this option to zoom selected. And then to deselect our vectors, simply click anywhere in the white space. So let's take a moment to look at our design and see how it's all going to fit together. So if we just take a look at this image, we can get a better idea of how it's going to come together. So we can see that we've got our vertical legs here, and we also have our base horizontal part and also the flat top, which is going to be used as the top of the seat. You'll notice that the top of the seat has all these mortise holes, which are going to be used to then slot in with the tenons on our vertical legs. So keeping that in mind, let's go back to the software and our design. In terms of the design, there is one important factor that we must consider when creating anything that uses a mortise and tenon type of slot. The thing that we need to keep in mind is the material thickness that we specified, 3/4 of an inch. We need to remember that when cutting around these shapes, these tenons are going to be 3/4 of an inch thick. So we need to ensure that any of the mortise slots that we have are all 3/4 of an inch wide. So if we just select one of our mortise slots, we can see in the lower right hand corner that we do have a height of 3/4 of an inch. And it also does give us the layer information of what layer that vector is on. So it's worth noting that if we didn't have 3/4 inch material, that we would need to change the size of these mortise slots to match the actual thickness of our material. Otherwise, we will simply be left with parts that do not fit together. There is also another thing that we need to keep in mind. So if we just zoom in on this mortise slot here by going to zoom selected, another thing that we need to keep in mind is that we're using a circular tool to then drill out the material to create this square shape. So if we for a minute just imagine that we're using a 1/4 inch tool, so I'm just going to draw a 1/4 inch circle, and what I'm going to do is I'm going to imagine that I'm the tool and I'm coming up to the corner, and I've drilled up as far as I can into the corner without overcutting. Now, as we can see, we are going to be left with an internal radius, obviously where the tool couldn't actually get in further into the corner. Now, this is going to cause problems also for when the tenons come to slot in to these mortise slots, as they're not going to be able to get in because of this excess material left on the corner. So we have two options we can consider. We can manually finish off all of these mortise slots and tenon joints with a file to make a true mortise and tenon joint, or with the CNC machine we can use something that's called a dog bone or a T-bone fillet. And what these are is basically it allows the tool to slightly overcut into the corners, and then when it comes to joining these two mating parts together, they will actually fit. So to demonstrate this, first I'm just going to delete the circle I've just created, and then I'm going to press F on the keyboard to zoom to fit. So I'm going to demonstrate this first of all with using the top of the stool. So if we just select the outer vector for that and then come to the zoom selected, what we're going to do is we're going to create fillets on all of the corners of our mortise slots. So to do this, we come to the create fillets tool under edit objects, and what we do is we specify the radius of our tool. So if we're using a 1/4 inch tool, we would use 0.125. And if we wanted to, we could also add some allowance to that just to make sure that it does overcut slightly into that. So we could specify 0.135 for that. And then I'm going to select to use a dog bone fillet. So simply select this option, and what we do is we just simply hover the mouse over one of the corners where we want to actually add a dog bone fillet. You'll notice that as soon as I get close to it and the software recognises that a dog bone fillet can exist there, you'll notice that little tick should come up next to the cursor, as you can see. So simply go ahead and add these to each of the corners of our mortise slots. So I'm just going to go ahead and add the rest of these. And what I'm going to actually do to demonstrate to you that this will actually work is I am going to close this. I'm just going to copy this square here. I'm just going to turn that into transform mode first, and then I'm going to just drag that over here, and you'll notice that now we've overcut into the corners. If you imagine that this rectangle is our tenon, now we've overcut into each of these corners, our tenon will fit into this multi-slot perfectly. The only downside to obviously this method is that we are going to be left with a hole in each of the corners. So you do have an aesthetic penalty to using dog bones. So let's just delete this rectangle and then carry on. So select the dog bone fillet tool again and just carry on. Now I've finished the ones on the top of our stool, so let's press F on the keyboard to zoom to fit, and now we can simply close this and then highlight this base part here, and then again press zoom selected and then do all the corners on these multi-slots here. So again, go to create fillets and select to dog bone these. Just make sure that you have the tick next to the cursor before clicking down with the mouse, and this will stop too many clicks happening. You can also, if you do make any mistakes, you can also hover back over the dog bone fillet and you'll notice that there'll be a next button there, and that will just replace the corner that we accidentally changed to a dog bone fillet. But in this case I do actually want the dog bone fillets in that corner there. And again, just press F on the keyboard to zoom to fit. Another thing that we need to consider is that each of these tenons is also going to have the same problem. So again, if we imagine that we've got a 1/4 inch tool coming in there, and on these corners we're again going to be left with a radius on these corners here. So again, we'll need to add dog bone fillets to each one of these tenons. So I'm just going to delete that circle there, and then I'm going to select the create fillet tool, and I'm just going to go around and add some fillets to each one of these tenons. You can choose to follow along, or you can choose to watch me first and then pause the video afterwards and just make sure that you've got all the dog bone fillets in all the areas that I have. Let's just zoom out there. The one thing that we haven't considered, however, is the fact that we are actually going to be slotting each of these parts into each other as well. So these are also going to have that same problem. They're also going to be left with an internal radius, and that's also going to stop the parts mating snugly. So what we can do is, again, we can choose to dog bone these as well. But for this we may want to just use a T-bone fillet. So if we select the T-bone fillet tool and we just come over to one of the corners, you notice that with the T-bone fillet you do actually have two options of different types of fillet that we can use. So you'll notice that the cursor is changing to let you know the different types of fillet that you can use. So if I just select there, you notice that we've got one that's facing 90 degrees away from the straight, and we can also use this one which goes straight down as well. So I'm just going to undo that, as I'm actually going to use the ones that go out to the side. So if we just go ahead and T-bone fillet the rest of them like that. And then just do the last slot here. And that's finished. So we can simply now just press F on the keyboard to zoom to fit. Now that we've finished adding dog bones and T-bone fillets to our vectors that we imported, we can now think about taking this to toolpathing and machining. So for now we're going to save our work. So if we go to File and then Save, and then I'm just going to call this 3 3LeggedStool, and I'm just going to put underscore vectors and save that. We can now use this file in conjunction with our toolpathing companion video. Don't worry if you haven't followed along for this one, we do have a pre-prepared file which you can use along with our toolpathing video.